Okay, so hi there everyone. Welcome again to our playlist in college algebra. And what we're going to do today is we're going to continue with our lessons in equations and functions, specifically about we're done with the evaluation of functions and we're going to talk about operations of functions right here. Okay, so just like in operation in arithmetic, we also have four basic operations and functions. So we have the sum function or the sum rule, the difference rule, the product rule, and the quotient rule. So what we do with them is, well, literally what we're also doing with arithmetic. In sum rule, what we're doing is we're adding functions. So um, try to observe on this. What we have here in the sum function is if we have a function f over here and a function h over here, where both of them are all in terms of x, what we're going to do is we're going to take the function f of x and h of x, and then we're going to add them together. So notice the plus sign here. So whatever is the sign here, same with difference, that's what we're going to do between the two functions. Note that some, again, I just want to emphasize this, some functions are commutative, so it doesn't matter which order we put. But in difference functions, it's not commutative, so the order matters. In the product rule, um, we have f times h of x. Some books would like to put the raised dot and write it like, for example, it may be rewritten as um, open parenthesis f times h of x, for example. Now, in the next rule that we will have, what we'll talk about is actually the composition of functions, wherein sometimes it is confused with that. So I would like to use the ones wherein they are beside each other just to see that it is still multiplication. It still denotes multiplication though. So again, we are just putting it here times here. So we have f of x times h of x. And lastly, the quotient function f over h of x. So we have f of x over here and h of x below as our denominator. F of x is our numerator, h of x is our denominator. And it's very important to write down and recall that our h of x can never be equal to 0, or else we will have an undefined statement. So let's take this as an example, and we will let f of x to be x plus 1 and g of x equals 2x squared. So we're going to solve the following given here. Just notice in our formula is we're using h, but here in our example we're using g. Nonetheless, remember functions can just change their names. The most common is f, which stands for obviously function. So let's start with an answer letter a first. Okay, so let's have a here. So a is f plus g of h, so that's the sum function. Um, f plus g of x. Okay, so we're going to write that as f of x plus g of x. Okay, so f of x, again, we define f of x as our x plus 1. Our g of x is 2x squared. So we're going to write them down. So we have x plus 1 plus 2x squared. And then the most important part is to combine them properly. So we can see that all of these three terms, there are no like terms between them. So we're just going to present this properly. So we can just rewrite this as 2x squared plus x plus 1. So that's going to be our f plus g of x, our letter A. Now, for letter B, Let's continue. We have f minus g of x, wherein we need to deduct g from x. So what we have is f minus g of x. So again, remember the difference is not commutative. So it's important to write down, and you need to very particular with the signs here, which most of the students get wrong whenever they write. They tend to forget about the signs. So please don't. Minus g of x. So what we have here is going to be x plus 1 minus, it's also an important practice to always, before the minus or after the minus sign, always put up an open parenthesis so that you won't get lost. Remember, parenthesis whenever we have a polynomial, a binomial at least, after the minus sign, and then we substitute it with something like a binomial or more, we need to distribute the minus sign to each of the terms. So what we'll have here is going to be x plus 1. It's going to be negative 2x squared here. So let's just write negative 2x squared in front, plus x plus 1. So that's going to be the value of our f minus g of x. Okay, and that's our answer for letter B, so f minus g of x. For letter C, it's product rule. So what we're going to do is we're going to multiply them. So f times g of x. So we know f of x, it's going to be written as f of x times g of x. So we have our f of x to be, x plus 1, open parenthesis, for it to be safe, times 2x squared. So we multiply both of them. Remember that we need to distribute the 2x squared to each of the term here. So we have 2x cubed, multiply 2x squared by 1. So that's identity property. That's going to give us 2x squared. Okay, so if you want to simplify, you can, but I think this is going to be enough if we're going to write it like this. Okay, now, and for letter D, let's have letter D as f over g of x. So that's going to be f over g of x. Okay, this is g. So this will be written as f of x over here, and g of x in the denominator. Again, it's also important to note that g of x must not be equal to 0. So this will be equal due to the lack of space. I'll just do this in a linear way. So f of x is x plus 1. G of x is going to be 2x squared. We cannot simplify this anymore. I think we will be contented to write it in this manner. And yeah, that's it for this video for now. I think it's a common practice to box the final answer. So let's do that here. So let's box this answer here for the sum, that's letter A. Okay, let's box letter B for the difference. Going to be like a crooked box. Not really. Not very crooked. Not really crooked, but it is very crooked. I'll try my best. Okay, something like that for letter B. And for letter C, let's box it. 2x cubed plus 2x squared. That's our answer for letter C. And I'll just box our final answer for letter D, which is this. Okay? And those are our answers for this set of video. Thank you very much. I hope you learned something from here. Um, I'll try to create more of this operations of functions in the near future, so that there will be a lot of examples right after this video. So thank you very much for watching. I hope you would like and subscribe, and see you soon. Okay, bye.